Okay, now the first day, we spent a lot of time me just trying to get to know everyone's name and all that. And we also went over some basic stuff from geometry. In math and geometry, a line, technically it has to go on forever in each direction. That's what the arrowheads mean here. Now, there's a few different ways you can name a line. The important part here is the symbols. So here, if I wanted to name this line, I can name it line XY. The symbol for a whole line above it, you have a line with the arrowheads. And it can be in either direction for the letters. X, Y, Y, X, same thing. Now, a line segment has a definite beginning and a definite end. And it is named for the endpoints. So the example here is AB, or it could be BA. The symbol this time can either have a line without arrowheads, or you can put the endpoints on it. Either one of those. Now, like what this means here, let's say we had another point there, X. If you wanted the whole thing, you can't use the X. You would have to say AB. Say you wanted just from A to X, you would have to just use for like the blue part here, AX, or you could use XA. The red part then would be XB. And just little quick definitions like this, they're not too hard. It's once we get to harder stuff, this will be used again. Now, array has an end or a begin. It has one endpoint, and then it goes on forever in the other direction. That's where the arrowhead shows up here. Now, same idea when you name it. So at A, it doesn't have an arrow going the other direction. So A, we have the dot on, and then you just put the other letter down and have your arrow. This symbol means ray. This symbol means line segment. This one means line, a full line that goes on forever and ever and ever in each direction. And like here, one thing I forgot to mention, let's say there was an X as well. You could use X just as long as the letter where the beginning is the one you start with, and then any other point on the ray. Now with angles, what an angle technically measures is rotation. Like if you have two rays, how much you would rotate one up to the other. It's measured in degrees. You already probably knew that. A whole, if you were to rotate all the way around in a circle, that's 360, a whole circle. A half circle, a semicircle, which would form a straight line, is 180. And like if you look at half of a straight line, cut it in half, this is 90. These are important angles that we'll use a lot this year. Now, naming an angle seems kind of silly, but we'll have to go over it. We'll have to use it quite a bit this year, actually. If we take a look here, this is kind of a mess. There's three possible angles here. You could have the top part right here, this angle. You could have just the bottom part of the angle here in red. Or find another color here. The whole thing will be in black here with a pencil lead. This is where the name becomes important. Now, one vocab word the corner of an angle or a shape. It's called a vertex. There are three possible angles here. When you name an angle, the letter in the center has to be the vertex. Then you just follow the rays that make the angle. Let's say we want the blue angle here. It's formed by these two lines. So put the vertex in the middle. You could use for the blue angle AXB. So there's the angle sign AXB. That would be the blue angle. You could do the order the other way with B first, BXA. These are the same thing. They both describe the blue angle. Now the smaller bottom red angle here then, X has to be in the middle. It's still the vertex. This one, BXC. So the red angle, I'm trying to color coordinate this all for you. BXC. Or it could be CXB. The vertex has to be in the middle. The big angle, the whole thing here, so it's made this time by these sides, these rays. The whole thing then, AXC or CXA. That would give you this whole angle. Now, this is called the three-letter name of an angle. You have to use it when there would be more than one angle. But if we just take a look at one angle where there's no choice, see, there's only one angle here, right here. This you could get away just by saying angle X. Or you could do the three-letter name, angle AXB or BXA. The angles here, this is the most important part of this little quick lesson here. If there's only one, you can get away with naming it by the vertex, the one letter in the corner. Or you could do the three letters, AXB. If there's more than one possible angle in the diagram, you have to use the three letters because it's unclear. All right. Now that was pretty much all we went over the first day. We also started, but we didn't finish. Just some practice solving equations. And then Tuesday, that's pretty much all we did. It was a little rough for some of us. My goal on Tuesday was to do this, then go on to do the rest of this here, but didn't quite work out. So Tuesday, we just practiced more equations after like this. And then Wednesday, we practiced some more equations and did these. So we'll just go over this whole thing all at once now. All right, hopefully this is review as well. Now, when you solve an equation, if you have some parentheses here with this number out front, you have to distribute. 2 times 4 minus 8, but then negative 2 times negative 6 plus 12b equals negative 113. Now, this was the rough part for a lot of people. These are on the same side. Like, I'm not going to subtract 3b under both of them here. They're on the same side, so I put them together. Same side of this line here. You don't have to draw this out every time, but it helps some people. So 3b plus 12b, 15b. Bring your minus 8 down. Now it's just like a two-step equation. Add the 8. Negative 13 plus 8 is negative 105. Divide by 15. B equals negative 7. Here we'll distribute for number 2. We get 6 times 1 is 6. 6 times 3 is 18. Minus 6. Yeah, 126. And now we'll divide by 18. V equals 6. All right. Now number 3, we distribute the 3, so you get 12k minus 7 times 3 is 21. Bring the rest of it down. This time, the k's, the variables, are on opposite sides. So now we're not putting them together. Now we want to cancel one of them out. And we can either subtract 3k from both sides, or we could subtract 12k from both sides. Either way will work fine. I'm going to subtract the 3, just so then I won't make a negative. 12 minus 3, 9k. Bring your negative 30 down. That cancels. Don't drop your negative. Add 21. Negative 30 plus 21 is negative 9. Divide by 9. Negative 1. Now, number 4, we'll distribute negative 3 times negative 3, positive 9. Negative 3 times negative 2, positive 6n. So again, we have variables on both sides. Most of the time, like on the last question, usually try to avoid making negatives. But this time, if I subtract 3n and move it over here, I'll have 0 on my left side and the number and a variable on the other. So that'll leave me with a 2-step equation. It's easier here if I just subtract 6n, even though it makes a negative 3. 3 minus 6, negative 3. This way I have all my variables on one side and all my plain numbers without a variable on the other side. Now I only have to divide by negative 3. 9 divided by negative 3 is negative 3. Okay. Now 5. So we'll distribute 8 times 8, 64m. 8 times 3, 24. Bring the 3m down. And then I'll just drop this side down. Oh, this is a mix. We have both variables on this side and some variables on the other side. Still though, these are on the same side, so we're going to put them together. 64 plus 3, 67m. Now we'll do the variables on both sides part. Now we'll try to cancel one of them out to get them all onto one side. I could either subtract 67 or I could subtract 2. I'll subtract 2. All right, this time there's numbers on both sides, so I don't have to worry about any zeros or making a longer equation or not. Bring that 24 down. 2-step equation now, subtract 24. Oop, running out of room. We'll go up over here. 65m. 24 minus 24 is 0. 0 divided by 65, or 0 pretty much divided by anything, is 0. Number 6. Distribute 6 times 1 is 6. Plus 36x. Variables on both sides again. And this time again, Since we have numbers that don't have variables on both of the sides as well, we'll just avoid making a negative. So minus 3x, minus 3x. Now over here, two-step equation, subtract 6. $39 minus 6, 33. Divide both sides by 33. X equals 1. All right. Now, even though this is geometry, we're still going to use equations a lot this class, which is why I reviewed them. What we ended up doing is we just practiced this the rest of the class instead of going on. I don't know what level of math you're at or whatever, so I'll just go on here. Now, it says state whether the relationship is a complement or a supplement. Complementary angles, some people had remembered this from 7th grade. Complementary angles add up to 90. Supplement add up to 180. So here we go. We want to find B. And we have a 90-degree angle, which means these are complementary. If all you have, if there's no complicated algebra or anything, like you'll see in a minute here, if all you have is just a number, all you got to do, 90 minus 38 equals 52. B is 52. On 8, this forms a straight line. A straight line is 180 degrees, like I said in the notes there. So this is supplement. And since this is just a number, 180 minus 46 equals 34. Same idea on 9. We got complement. 90 minus 29 equals 61. 10, this is a straight line here. So we just have 180 minus 112, which equals 68. And 11, that's a 90-degree angle right there. So this is complement. 90 minus 25. 65. All right. Now, like I said, if it's just like a number, all you got to do is subtract. But here, we get into having more algebra with all of this. So instead of subtracting, it's easier to do this just because we have x's and other numbers and all this other stuff going on here. This is a 90. So these are going to add up to 90. So x plus 9 is that part of the angle, plus the other part, 61, equals 90. 90 plus 6, or 9 plus 61, 70. Subtract 70, 20. This time, straight line, so they'll add up. So there's one angle, there's the other. They add up to 180. Negative 20 plus 150, those are on the same side. So I combine those like terms. This is why we practice those equations. Negative 20 plus 150 is 130. Subtract 130 from both sides, 50. Oh, back to one of the 90-degree examples here. 5x plus 4. There's 1 plus the other equals 90. 4 plus 26 is 30. Minus 30. You get 60. Divide by 5. 12. 15, same idea, but now straight line. Ooh, we got more x's. So 2x plus 9 represents this angle. 6x plus 3 is that angle. They form a straight line, so they are supplementary. All this stuff is on the same side, so I got to combine like terms. 2 plus 6, 8x. 9 plus 3 is 12. Subtract 12 from both sides. You get 168. Divide by 8, 21. Now 16, this one plus that one, they form a 90-degree angle. So 4x plus 1 plus 2x plus 11 equals 90. These are on the same side, so we'll put them together. 4 plus 2, 6x, 1 plus 11 is 12. Minus 12. Divide by 6, divide by 6. 13. All right. So those are like the notes and the practice problems that I did with everyone last week. Now, a lot of the work we're going to do, I doubt, I don't know. Maybe you used Delta Math before, maybe not. It's going to be on something called Delta Math. So I got to share, I got to present here. So Delta Math, deltamath.com says 4 students. Click where it says 4 students. And then register. You'll need a course code. And that's what I'm going to give you here, the course code. Let me look it up. For geometry. And then as you can see, it just pops my name up. Class, you're in period 3-4. So this is the code that you want to use. QN2D-N6B. Type it in just like that. You can register with other email if you want, or you can use your school email through Google. Then you'll get in there and you'll see some assignments. Let me go in now and I'll extend some of them. So after you get in there, I'll extend the due dates. After you get in there, you'll see some. Just give them a try and let me know if you need any help.